So let's talk about trig graphs from the beginning here. In the last lesson, we kind of spent most of the time playing around with the idea of trig graphs and asking questions. But the thing that you need to really know are these three main trig graphs. So this is the sine graph, then we've got the cos graph, and then we've got the tan graph. And you'll notice that the sine and cos graph kind of look similar. It's almost just like that the one is a little bit ahead of the other, whereas the tan graph looks quite different. So that's something to point out. Now, as we look at these graphs, one of the things that we spoke about in the last lesson was how the sine and cos graph by default have a period of 360. So you can see that you fit one whole wavelength or one full cycle in 360 for the sine and for the cos. But when you get to the tan graph, a full cycle fits into 180. So that's an important idea. The period of the graphs can change, and we'll cover that in the next lesson, but the default period is normally where we start from. So that's something that's quite important. The other thing I want to point out is if you look at the behavior of the sine graph, you'll notice that it's positive, positive, negative, negative. And over here for the cos graph, it's positive, negative, negative, positive. And then if you look at the tan graph, it goes positive. It goes, because it's 90 degrees, it goes positive, and then it goes negative, positive, and then negative. Give me a thumbs up if you understand what I'm talking about with pluses and minuses. In terms of visually showing you the graph, where the graph is positive, like, for example, 90, the sine of 90 will be equal to 1, and that's a positive value. That's why it's going to be positive there. So just let's make sure that everyone is on the, okay, now, what I tried to do a little bit in the last lesson, I'll try again now, is I'll connect this up to the cast diagram. And what we know about the cast diagram is everything is positive in quadrant 1. So if you look at these graphs, quadrant 1 is 0 to 90. All the graphs are positive from 0 to 90. Then what you'll notice is that sine is positive from 90 to 180. So I'll put a sine there. But the other two graphs, the cos graph is negative from 90 to 180. And the tan graph is also negative from 90 to 180. So I just want to take a moment and check, do you understand why on the cast diagram, we say everything is positive in quadrant 1, but only sine is positive in quadrant 2. And this comes from the other parts of trig, but I think it's important we just connect these up a little bit. So only sine is positive between 90 and 180, and you can see this visually on the graph. And I just want to take a moment so that you start to think, oh, these two things are connected. Okay, and so if you look at quadrant 3 is 180 to 270, sine is negative, cos is negative, but tan is positive. So that is over here. And so we would say that that's why there's a t here, because t is positive. And then the last one, if we look at quadrant 4, sine is negative there, cos is positive, and tan is negative. So that's where the cast diagram comes from. It tells you where cos is positive. It's cos is positive in quadrant 1, where everything is positive, and in quadrant 4, and visually you can see it. So all I want to check is that you all understand how the cast diagram is related to the graphs. Give me a thumbs up if you understand the relationship between the graph and this drawing. And give me a thumbs down if you don't. Okay, now I want to ask another question. I want you to focus in on y equals tan x. And I want to give you the trig equation, the tan of x is equal to 1. That's a trig equation. And if you look at that trig equation, can you solve that equation for me using the graph that you have here? So if I say to you tan of x is equal to 1, can you solve for what x is? And do you understand what it's asking if I look at that graph there? Who would like to give me an answer? I feel like someone's going to pop their hands up and give me an answer. Because I know you can do it. Yes, you can. Who feels like they know? Oh, I see Morgan has put an answer in the chat, and so is Sippy Sinclair. And they are going for 45 degrees. Would anybody like to explain why they think 45 is correct? I suppose you could put it in your calculator, and that's one way you can check, but what else are we looking at? Let's go to you. I see your hand is up.
Afternoon, sir.
Hello. What do
you said
yeah.
10x equals to 1.
Yes.
And on the left hand side we have y equals to 10x and 10x equals to 1. So we have to substitute x to 1, and for us to get the angle, we have to press shift and then we press tan. We put 1, close the bracket, and it will give us 45 degrees.
Yes. So you've used your calculator. So you've gone shift tan of 1, and you have got the answer of 45 degrees. And then Fabian has said, if you look at the graph, what's in line with 1, it's 45. And both of you are correct. X is equal to 45 degrees. Now, for bonus points, I would like to know another answer to this that you can get by looking at the graph on the screen. So if you look at the graph, there's another answer on the screen, and I want to know, can you work out what that is? So you found me one answer, x is 45, but what is another answer? Morgan, you're on fire today. Annie, the same thing. Would any of you like to explain how you got 225? I mean, it seems quite different to 45. How did you figure that out? Who would anybody like to explain where they got it from? I mean, we can check it on our calculators. Anybody? So can anybody explain? So the question was, I want another answer to this equation. And lots of students are saying x is 225. And you're right. If you put this into your calculator, the tan of 225 is 1. And the reason we know that is look across here. This is what the students have noticed. Sorry, Morgan, I saw your hand just go up there. Is that 225 for the tan graph is in line with 1. And that's why we know there's an answer. And one of the things that's important about trig graphs is they repeat themselves, or they're periodic. And so that's why when we have trig equations, we always have what's called general solutions. There are solutions that repeat themselves. And there's a whole separate 2 lessons on the Watobe website about how to solve trig equations. At the moment, because we're doing trig graphs, I'm just doing them by inspection. But there is a whole process that we can go through. Okay, that's the review for today so far. That's nice and good. So that I like what I was seeing there. And then what we're going to do now is we are going to learn how to draw graphs effectively, but with some changes. So say, for example, I don't want to draw y equals sine x anymore. I want to start drawing something a little bit more exciting. So what I'm going to try and draw here is I'm going to draw y equals 2 sine x. Now, this is a change from a basic sine graph. And the type of change we call this is an amplitude change. It affects how high or low the sine graph goes. And so one of the things I want to show you today is how your calculator can possibly assist us when it comes to this type of thing. So let me share my screen, desktop, and then can you all see? Give me a thumbs up if you see a calculator appear on screen. And then label just to make sure you can't see any video thumbnails at the moment. It's just me that you can see.
Yes, no, just you and the screen and the calculator, Mr. S.
Fantastic. Okay. Now, if I want to draw this graph, I know what I'm doing. It's fine. I know that I start from here. But your calculator can be helpful if you know a couple of things. First of all, you need to decide what the domain is on which you're going to draw this graph. And the domain here that I've given you for this question is 0 to 360. Then to draw this graph, we also need to know the step size. And the step size for the sine graph is going to just be 360 divided by 4, or the period divided by 4, which is 90. Okay, now, how does my calculator help me do this? If I click mode and I click table, and then I put in there, I want to put the function that I want to draw, which is 2 sine x. So I'm going to type 2, then I'm going to type sine, and then I'm going to go alpha, which is the red one, alpha, and then there's an x, where there's a red x here. And I close that. Now, I just want to give everyone a chance to catch up if you've got a calculator. It's a very similar way. If you've got a sharp calculator, you can also go to mode and you type table, and then it gives you function 1. So I'll just wait a second for everyone to catch up. Now, what we do is we hit the equal sign. If we hit the equal sign, some of you will say g of x equals, which is a second function. I don't need a second function now. I just want 1. Some of you may not have this at all. If I hit equals again, it says start. So now I'm going to put 0, because 0 is where I'm starting in my domain. Like if I look here, it's starting at 0. So I've got 0. Then I go equals. Now, where do I want to end? Put in the chat, where do you think I want this to end? We're about to start drawing the, about to start drawing the graph. Okay. Sorry about that, everyone. So we put 0, 0, then we put 92, then we put 180, 0. Now, if we go to my calculator, we go down, we get 270 minus 2, so 270 minus 2, now that would be down here, and then 360, 0. And so using these points, I can now draw my graph by going up, down, down, up. And so this would be the graph of y equals 2 sine x. Now, that is how I would do it. I want you guys to try and draw for me using the same idea. I want you to draw for me the graph of y equals 2 cos x. And I want you to try and use your calculator in the same way as I did now, and see if you can do that. I'll give you some time to attempt it. And if there's some questions about the calculator, yeah.
Mr. S, can you please go through the steps again to use the calculator to put those values?
The second time we do this, we're going to be drawing the cos graph, right? So we want to draw the cos graph, and the basic cos graph has been changed because of the 2 in front. And so we're going to use our calculator. So we go to the calculator, and let me even put up the key log so you can see the keys as I do them. So, okay, I said on. Let's see if I can, oh wait, there we go. Okay, mode. So I click on mode, and then I click on 3, which is table. And now I click on 2, because I wanted 2, and I click on cos. Now I have to click alpha. So alpha, and then I click the red one and I get an X, and then I close that. Okay, now I go equals, and I start at 0. I end at 360, and my step size is 90. Don't know if I'm going a little bit too fast in Basa, just let me know. And then I hit equals and I get to the promised land there. And I start putting my dots on this. So I want you to have your, for those who are drawing this, I want you to have your graph set up. So you'll have a 1, 2, and then a -1. And what is my very first point? My very first point seems to be 0, 2, which is this dot here. And then it seems to be 90, 0. For those who are unsure, I encourage you to raise your hand. I'd love to have a conversation. We can actually do something on the calculator live as we do this. So I encourage you to ask a question in case. Akanani, have I lost you there? Just let me know. So 180 minus 2 is down here. And then I need to go further down. I hit the down arrow. I do 270, 0. And then what is after that? I get 362, which is up here. Okay, I'm going to do another one in a moment, everyone, so don't worry. So what I've done is I'm looking at these points over here. So if you look at this process, I started with 0, 2, which is here. Then it's 90, 0, which is here. And I'm drawing the graph of 2 cos x. And what it looks like is like this. And if we are doing it properly, we should actually label the points of the turning points there. The rest are fine. So this point over here would be. So what I'm doing is I'm using the calculator to help me understand how this behaves. Now, before I move on to another graph, I want to ask you a question. For this trig graph that we've just drawn, what is the range of this trig graph? What is the range of this trig graph? You can put your hand up and or you can put it in the chat. What is the range of this trig graph? So the range, remember the range relates to the y values, and it looks to me like the biggest y value that I get is 2, and then it stays between this zone over here. So that's the range of this trig graph. And so we would say the range is y greater than or equal to -2 and or less than or equal to 2. Or if we used interval notation, we would do it like that. And what we notice is the range is a lot bigger because the graph has been stretched upwards. This 2 stretches everything up by 2. And so the range is a much bigger space. Okay. Now, I want you to draw, let's try and draw another one of these. I want you to draw for me y equals 1.5 sine x, and I want you to do this on the domain 0 to 360. So I want you to draw for me the graph y equals 1.5 sine x, and I want you to draw it, and I will help you on the calculator to show you what we do. So we go mode, let me clear all this. We go mode, and then we go to, wait, let me go back again. Mode and 3. Okay, now I'll give you a bit of time to do that. And then I encourage those students who are feeling lost, I'd love to have a conversation with you, because I've got this calculator ready to rock and roll. I'm ready to show it off. Yes. What's your question?
So is it possible that they won't give us the step of 90 degrees, but they might give us a step of 45 or any other one?
Okay. That's going to happen when we change the period of the graph. So if we could fit like a whole graph in 180, for example, like if it went like kind of like that, then we'd be talking about different step sizes. But at the moment, the only thing that I've changed is this thing in front, and we call this the amplitude. It's an amplitude change. It's stretching the graph vertically. And so you don't need to worry about that at this stage, but I will show you other types of transformations later. Yeah. Ooh. 1 point. Let's wait, let me go. Is that a point sign? Where's my, okay, 1.5. We're going to find out now if that works. Sine alpha x. Actually, my calculator is being weird. I'm going to make it 3/2 because 3/2 is the same thing. So 3/2, and then sine alpha x, and we go equals. Now you can ignore this, so you just go equals again. We start at 0. We end at 360, and the step size is still going to be 90. So what are the points? We seem to start at 0 again. Then we've got 91.5. So let's make that 1.5 up here because it's like 0.5 per each of these. So let's make that 2, that 1. Then I've got 180, 0. And then I've got 270, 1. So 270 minus 1.5. And then what's the last one here? Oh, 360, 0. And so when I draw this, you actually notice that this thing over here is quite important. And my sine graph is going to go to the highest point here, lowest point there, and like that. And I want to ask you, what is the range of this graph? Ayanda, it's showing different values for your Casio. Is it possible, Ayanda, that your Casio calculator is on not degrees, it's on radians? So look at that little D in my table. If your table doesn't have Ds, if it has Rs, then you need to change the setting. Okay. So let's have a look here. So I think the lowest value is 1.5 and the biggest value is 1.5. And so that's the way I would write the range of this graph. Or I could write square bracket minus 1.5, 1.5, or 3/2, and I get that. Okay. I want to squeeze in one more before the break. Okay, so the last one that I want us to try is, what if I ask you, can you draw for me y equals minus 2 cos x? So I want you to try by yourself now using the calculator. Can you draw over the domain 0 to 360? Can you draw that graph? Over to you guys. See if you can do that. And I'll just take this one out. The domain, good question. The domain is still 0 to 360. I'm not varying the domain yet. mode table. So what's this going to be? -2. Uh, 180 then. $270 is 0 and 360 is -2. So where the calculator is really nice is it helps you know where the dots go. And then once you've got the dots from the calculator, it can help you draw the shape, right? So this used to be like this. And you can kind of imagine what happened with that -2. Maybe somebody else can help me understand. Now, the other thing I haven't done is I should be labeling my turning points and my endpoints. That's generally something which is required. And you also need to label the graph itself. But it's just I don't want to be obsessed with that at the beginning. What does the minus do? What does the -2 cos x seem to do here? Who knows? Who has an idea? Like, what did the normal cos graph or the normal 2 cos graph? Yeah, so Mdudu has said it flips the graph. So this graph has been stretched because of the 2, and then it's been flipped because of the minus. So there are actually 2 changes that are happening here. And so it's important to realize that this is where the calculator is really your friend. Give me a thumbs up if you're feeling okay with what I've been talking about. Give me a thumbs down if you're feeling a bit lost. I just want to get a quick feel for the group. Okay. Fantastic. Okay, let's have a quick break. We lost a bit of time today, so I'm going to take a short break. Let us stand up for a second. I think it's going to be pretty dark, so I'm just going to leave. Can you see me? I think my camera can just about. Nope, it's too dark. So what I want you to do is I want everyone to just stand up for a second, and we're going to do a speed break. So I want you to just stretch out your arms and swing them a little bit. And then I want you to kick out your legs.
Cameras, guys. Let's see your lovely faces.
So kick out your legs a little bit, then do some circles with your arms. And then change direction. So go the other direction. Then just twist from side to side. Oh, this feels good. And then maybe a last one, just a stretch of the tricep stretch. Okay, and then let's just do 10 air skips. So I've got my virtual skipping rope. I'm just going to do 10 skips. So let's go. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, and let's stop there. Okay, so that was an abbreviated break today, but I do think that you get a feel for kind of just, yeah, pausing for a second, which is helpful. Okay, now let's look at a similar idea, but extend what we've been learning. So what we notice about this thing is the domain is bigger. And what we're going to do is I'm going to actually ask you to draw 2 graphs on the same kind of axes. And I'm going to introduce something new here. So what I'm going to do is I'm going to ask you to draw the graph of y equals sine x plus 1.
Oh, Mr. S, can you please drop your camera?
I can, yeah. So y equals sine x plus 1. And then I'm also going to ask you to draw the graph of y equals 2 cos x minus 1. And the domain that I'm going to give you is going to be from minus, let's make it from minus 180. So we're going to go from minus 180 all the way to positive 180. So that's going to be the domain. And I'm not going to say too much more about what's happening. I'm going to let you try and use the tools that I've introduced so far today. So I want you to draw 2 graphs on the same set of axes in that domain, and then we'll talk about what's going on here. Yeah, let's go to Kawotso.
Sir, I'm already done with my calculations.
Okay.
And there are many decimals on my calculators, and I studied about them.
But here's the problem. Did you start with minus 180? Because remember before you were starting with 0. Now,
yeah, I did all the procedures correctly.
Okay. We'll talk about this in a moment. But let's just start with the green one. So let's tell me if this was what you did. So I'm going to put in here sine of x. And then did you put a plus 1 like that?
I did like that, but the problem was that I didn't close the bracket of the x. That's why.
Perfect. That's why I love being live on the internet. It's just so nice to. So clearly closing that bracket is really important, everyone, because if not, and I understand why, it thinks you're doing a horizontal shift. Now, what this plus 1 is doing is actually shifting the whole graph up by 1. But if you don't close the bracket, the calculator thinks the 1 is somehow related to the x, which confuses it. Yeah, good question, though. Now, I could do a second one at the same, but I'm going to do one at a time. So I'm going to go minus 180 equals, and then plus 180. And my step size is still going to be 90. Okay, so I need to make sure my scale is appropriate. So 1, 2. Okay, so I seem to have dots over here, over here, here. And so my graph is going to look like that. I'll label this. Oh, I drew it in blue, which wasn't the best. But anyway, that is. Let me leave the labels out for now, otherwise I'm going to get a bit cluttered. Now, I've drawn the graph of sine x plus 1, and part of me feels like it makes sense because the whole sine graph has gone up by 1. So I'm pretty happy with I'll call this the function f. So we'll call this f. Now, what about drawing this graph? I'm going to have to I mean, you could have done it at the same time, but it gets a bit confusing. So I'm just going to start again and go table. And then I'm going to go 2 cos x, close my brackets, minus 1. Then I've got equals minus 180 plus 180, step size still 90. And I get something like that. I'll give you some time to see if you get the same thing. And also I need a bit of extra bit of runway here, it seems. Because I've got a minus 3. I'll make it red dots. So minus 180 minus 3 minus 90 minus 1 0 1 90 90 minus 1, so back to here, and then 180 minus 3. This is interesting. Now, what I like about the dots is when you think about how a cos graph normally looks, this is just a cos graph that's been stretched because of the 2. So the 2 we know stretches it upwards, or changes its amplitude, and the minus 1 brings everything down. And so the cos graph's shape will look kind of the same. There's my dots. And I'll call this G. And let's put our labels in now, because that's often in exams, it is important. So that point is an endpoint. That's 92. This point is what's this one? This is 180 minus 3, and that's about it. So this was a much harder example, and what we did in the first one is we just simply, in F, we shifted the whole graph up by 1. So everything went up by 1. Whereas in the second one, we had 2 changes. We had a amplitude change, or the graph was stretched vertically, and we brought it down by 1. Give me a thumbs up if you're feeling okay. Give me a thumbs down if you're feeling not so confident. Because I want to do some tan. I feel like we've neglected tan, and tan needs some attention. If everyone is on board. Okay. Well, I tell you what, let's draw. Now, what we must be careful of with tan is, let's start by first drawing the graph of tan x. And I want you to draw this graph on the domain 0 to 360. So start by drawing me the graph, and I will give you a little warning. What is the step size going to be? Oh, the step size is actually still going to be 90. It's just going to be the period divided by 2. See if you can draw me the tan x graph. I'll give you some time on that domain. The mode. Tan x start at 0. Ooh, this is interesting. So it says there's errors. What do the errors mean? Undefined, yeah. Or another way of saying it is there's an asymptote. So the calculator is telling you, but now I'd like a few more points if I can, or if I know the shape, I know what to do. It's not wrong. You could go back and say, what is the step size, and make it like, if I go back, can I go back here? Let's see if I can, or if I go mode, table. Okay, so if I want more points, okay, all I need to do, but I think a lot of you know the shape of the tan graph, so it's fine. But if I start at 0 and I find that I don't have enough points, I can change the step size to be smaller just so that I have more points. Now, I don't think you don't necessarily always need to do this, but it's nice to know that you can. So like, for example, if I want to know, okay, 45, 1, and 90 is still an error. What's 135? Oh, that's at -1. So let's say it's down here. 180 is 0. We know that. 225 is 1. 270 is 315 is -1. And so if we like, we can help get the shape of the graph by just putting in some extra steps. And that will help us draw the graph. Give me a thumbs up if you understand how you can change the step size to give you more points. Just want to make sure you understand how you can change the step size to give you more points if you need. Okay. Awesome. 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 All right. Let us draw the graph of y equals tan x plus 1. And I want you to draw this on the domain -360 to 0. So you're going to draw it on the domain -360 to 0, and you're going to draw me the graph y equals tan x plus 1. In terms of the changes, the +1 is just a vertical shift upwards by 1. That's what I think, but let's see if the calculator agrees with us. And that'll be our last one for today. Let me use my different comments here. -180 is 1. So this feels like another one where it might be nice to have a few more points telling me what to do. Or maybe you can see the shape yourself. I don't know, everyone's different, but and then 0, 1. Yeah, I'm going to go back and add a few more points because I feel like I go mode. Let's say plus 1. And I'm going to make the step size 45 because it feels like that would be more helpful. So minus 315 is 2. So I kind of know, okay, this is going up like that. And then I can go minus 181, minus 1352. So it's the same thing over here. It feels like that is that right? Minus 1. No, that's not right. Let me go back. So minus 181 is there. Minus 1352 is there. That's correct. Minus 225 is 0, which is there. Ah, yes. How helpful is this? And then minus 90 is an error. Minus 45 is at 0. And then 0 is at 1. And so what we should have is this happening. Yeah. And then that goes up to 1. That was quite a tricky one because the graph has kind of been shifted up, but it's visually hard to show that. And we can add more points if you need to, if it makes it any easier. All right, Lebo, could you put the link to the quiz in the chat? Everyone, I think we've done, so just to revise what we've done today, we've looked at what's called a vertical shift, which is basically when the number on the end shifts the graph up or down. And we've also looked at the number in front called the amplitude change. So if I had to just sum up, I kind of lost my thing here. Basically, we looked today at the number in front, which changes the amplitude. And we also looked, after that, that sort of stretches it vertically. We also looked at what happens if you shift the graph up or down, and then how to use our calculator to help us in that process.